Welcome back to Math 103. This is video number 24 on growth and finance. The very first $3,000 payment out of all the 41 payments that are made gets to sit in the bank the longest. It's made at age 25, and it grows from $3,000 to 3,000 times 1.07 to the 40. So because that particular $3,000 sits in the bank for such a long time, it grows quite substantially into almost $45,000, precisely $44,923.37. So the contribution made to the full sum by just that one payment is quite substantial. By contrast, your final payment, the one made at age 65, which is the end of this whole process and the day that we tally up the results of all those years of investing, that final payment of $3,000 has no time to earn interest. This means that the deposits that you make at the beginning of your career will have much more impact than the ones that you make at the end of your career on your overall savings. Now we're ready for a contrasting computation which is very important for your financial knowledge. What if, in the previous example, you waited until the age of 35 before starting to save for retirement? At the end of the year when you're 35, you make your first $3,000 deposit, and that continues until you turn 65, and at the end of that year, you make your last $3,000 deposit. The question is, how much would there be in the account at the end of that year, the year that you turn 65? We approach this problem in the same way as the previous one. We start out writing the first few terms and last few terms of the full sum that we would have to compute if we didn't have a formula. It's worth doing this first to be sure we know what we're talking about. We're going to apply the formula to find the future value, to find the total value of this sum. However, we have to make sure we understand all the inputs. As before, $3,000 is the amount of each payment. As before, 7% is the annual interest rate as a decimal. Now, however, there are 31 payments instead of 41 payments. Just another comment on why it's 31 rather than 30. Notice how, if you look at the exponents, if you counted 1, 2, 3, etc., all the way up to 30, 1 through 30, that's certainly counting 30 separate terms in the sum, but that's not all the terms. There's one extra term here. Right? So there are 30 plus one more is 31 terms, 31 separate payments. We substitute these values into the formula, 3,000 for PMT, 1.07 for 1 plus I, 0.07 for I, 31 for N. We compute $306,219.12. Be sure to do this computation and make sure that you're getting this number. Lo and behold, this is the amount of money that will be in your retirement account if you start saving at the age of 35 instead of 25. And that is quite a bit less than if you had started at 25. In particular, if you had started saving $3,000 a year at age 25 and invested at 7% annual interest, you would have accumulated almost $650,000 by age 65, whereas, as we just computed, starting at age 35, waiting just 10 years, would reduce those accumulated savings to just over $300,000. To put it another way, what does it cost you to wait those extra 10 years until you're 35 before you start saving? It's the difference between that $643-something thousand and the $306-something thousand. That difference is $337,609.59. Let's think about that. That difference is more than half of what you will eventually accumulate if you start early. To put that another way, where is all this extra money coming from? It's coming from the first 10 payments and what they eventually grow into, right? That's what this sum has that sum doesn't. That's what the sum that results from starting at age 25 has, that the sum that results from starting at age 35 doesn't. This sum has the effect of these 10 payments and what they grow into. These first 10 payments are accounting for that extra $337,000 of value in this big sum right here. The very important conclusion is that you miss out on a huge portion, more than half, of what your accumulated savings could have been by postponing the start of your saving strategy by just 10 years. The earliest years in which you save end up contributing a disproportionately large portion of your accumulated savings later on. This is very important for you to understand. Everyone who's in college, whether they're taking this course or not, should see this computation. And this is because the financial decisions that you make in your 20s and 30s, such as starting to save sooner rather than later, can have an enormous impact on what financial decisions you're actually able to make later on. You probably don't want to be in the position later on of not being able to afford to stop working and of having no choice in the matter. Making smart choices in the present affects your ability to make choices in the future. Before going on to the next video, answer the following question. Suppose that at the end of every year, starting at age 28 and to continuing through age 70, you invest $3,000 in an IRA with an APR of 4.5% compounded annually. Same setup as before, but just some different numbers. How much will the IRA be worth at the end of the year when you are 70?